In part 8 of alcohol, we are going to discuss about ether in general formula, that is RO dash. Its preparation we will discuss here with the preparation, mainly Williamson synthesis. Its mechanism, example, as well as its limitation. Very important one. Before that, some introduction of ether. Ether is a derivative of alcohol or phenol. We all know that alcohol general formula, that is ROH. Here H is replaced by either alkyl group or aryl group, whatever. That means carbon containing group. Is any carbon containing group replace this hydrogen, it will prepare this one, that is ether. So ether, R and R dash both are carbon containing group, like alkyl group, say methyl, ethyl, propyl, like this. Aryl group, it may be benzene ring, like this, or the product derivative of phenols. Phenols means benzene ring having OH. In that case also hydrogen is replaced by alkyl group or aryl group, whatever. So this type those type of compounds are known as ether. Now here another thing we have to remember, that if both alkyl groups are same, identical, equal, then only it is known as symmetrical ether or simple ether. Whenever they are not identical, same, it is known as unsymmetrical ether or mixed ether. Example I am giving over here, symmetrical, we may simple way we can write down this way. That means this one and this one is identical, R and R dash both are identical. It is symmetrical one, that is methoxymethane. Similarly C2H5, C2H5, both of the cases, that is also symmetrical. Lots of such examples are there. I have given only one. Now in case of unsymmetrical one also, I think it's from the definition it is very much clear. If we write down this way, so it is known as unsymmetrical or mixed, we can say. That means both are different. The name is methoxyethane. So whatever, so these are the compounds. Aromatic compounds, aromatic ether can be there. So it is, say, it is aromatic ether. So it is also there. Actually its name is anisole. It is anisole. We have to remember the common name also. It is a common name. So it is methyl. That means here phenol is there, OH, hydrogen is replaced by methyl. So it is also the ether. So whatever, so this is the introduction of ether. Now moving to the preparation in case of Williamson synthesis. In Williamson synthesis we have to use sodium alkoxide, sodium alkoxide plus alkyl halide preparing ether. Ether is prepared by this manner. Now in general I am writing over here, say general reaction, what I can write, that is alkyl ether, say R dash halide. Halide means X. That means it is producing RO R dash. Okay. Now the mechanism, how the reaction is happen. Actually this is the sodium is the strong electropositive element, so that's why this is the positive part, this is the negative part. So from here we can find out RO minus, that means O negative is there, and R dash X, that means here this X having the minus I effect, electron dragging effect, so this R dash having lacking of electron, so it's required electron, so whenever they are interact with each other, this negative, that means electron is donated, a bond is formed, as well as this is open up, this bond has been broken up, so R dash plus X minus, so whatever, so actually this X minus is added with Na plus, so forming Na, so whatever, if Na plus is added over here, so finally you are getting NaX, so whatever, so this is the mechanism, simple way we can elaborate the mechanism. Now moving towards the specific reaction. Specific reaction, one specific reaction I am giving over here, CH3ONA reacting with CH3 BRC. So what will be the result? I think it's very much clear. It will react this way, that is symmetrical ether is prepared along with NaBr. So this is a symmetrical one. Unsymmetrical also can be prepared. Now here also, so the product will be this. I think it's very much clear. Now in case of aromatic ether, what we have to use? Now this is used here over here along with say CH3Br. So this will attack here and it is open up. The product will be this. As I told earlier, it is anisole. Anisole has been prepared along with NaBr. So this is the way by which we can prepare uh, ether by Williamson reaction. So this is aromatic. Now some limitations we are going to discuss about some limitation examples. I have given some limitation. Some limitation like that. That means whenever in case of mixed ether, in case of mixed ether, when R is primary alkyl group and R dash is tertiary alkyl group, say the ether is CH3OC, CH3, CH3, CH3. So this is the tertiary alkyl group and this is the primary one. Now two options can be there. That means look at here. That means alkoxide, one part will be alkoxide, other part will be halide. So which part we have to use? Other one part will be alkoxide and other part will be halide. Now which part we have to use? We have to think about it. Now here we have to remember that whenever that means two parts are there, halide part is there along with other part, what you will say, that means alkoxide part is there. So which part should be taken as red? Now two possibility I am giving over here. That means CH3ONA is taken along with CH3 Now it is pure. Now here is a mind that here is a possibility. Another possibility is CH3 Br I have taken, and it is taken as a alkoxide. Now which is favorable? Which type of reagent can produce exactly this compound? The thing is that whenever we are taking this one, it cannot prepare this one. It will prepare the different thing. That means it will prepare alkene plus methanol here. Methanol. That means the product will be like this: CH3 CH3 double bond CH2 plus CH3OH plus NaBr. But here if we take this one, you will prepare this product. If you write down product A product will be prepared. So exactly this one. So this is the limitation we have to use. So we have to select. We have to be selective. That means which part we have to take halide and which part alkoxide. Now the another thing we have to remember, that another limitation I am discussing over here, that is in case of aromatic ether. Already we have discussed earlier, if we try to prepare anisole, we cannot use this one. We cannot prepare the product, but whereas if we use this one, we can prepare anisole. So the thing is that these are the limitations we have to remember, as well as diaryl ether, as well as this is the third one, and third one I am telling you, diaryl ether cannot be prepared by this method. So these are the limitations also. The question may be asked from this part also. So hope that we have cleared it up. What is Williamson reaction, which mechanism, as well as its limitation. Question again I am telling you, question may be arise from the limitation parts also. So not only we will go through the Williamson synthesis, but also the limitation part we have to learn.